What's up, guys? This is Professor Al-Jafri from ITI1120E, and in this video I'm gonna go over the solutions for all the questions provided in these two versions. So let's get started. The first question here, I'm giving you a program, and in this program I'm asking you to determine the complexity of this program in terms of a big O notation. So in other words, I want you to tell me exactly how many times I'm going to do the print of a star here in terms of the big O, and how many times I'm going to do the print $sign here. Okay, so remember, what's the big O? I have covered the big O in 3 classes and 3 lectures, and the big O is a hardware independent way of measuring the growth of the running time for a given program. So in order to solve this, we're going to ask ourselves, how many times do we need to execute this line of codes? This one will be executed just one time, and this one will be executed to n. So based on the value of n that we entered, this one is going to be executed to of n. So print star will be executed to n. And in terms of a big O, we're going to discard the constant, though this is an on. All right, so the good answer here is A. Okay, so now let's take a look at the second questions at which I've asked about how many times I'm going to execute this line. So remember that this line require 1 time to be executed. This one require 2 of n. This one require 2 of n, and this one require 2 of n because it's inside the indented body of the for loop. Now for the while, okay, so at the while loop we can see that we are dividing the k, which is the counter, over 3. So that's something similar to the mystery function I provided you. So whenever I am doing halving or quartering or even flooring by 3, this will be log to base 3 of what? Of k. And since k equal to n, so this is equal to n. And since it's indented with the 4, this is n log n. Okay, so the answer is what? N log 3 of n. So it is here E, n log n. All right, so let's move to the second question. So in this questions, I'm measuring your understanding of the an important topic, which is the order of execution. And this question is something similar to task 4 in lab 4. Okay, so remember, Python will read the lines sequentially from top to down. So at the beginning, it's going to go to this line. Okay, so line 1, and see it's a function definition, so I'm going to skip the indented body and I'm going to go to line 4. Okay, so after I go to line 4, I'm going to see it's a function definition, so I'm going to skip that, and then I'm going to go where? To line 7. Okay, at line 7, as we can see, it's a function call here. Okay, so I will go back to the function definition of times 3. So times 3, so I have to go back to 4, and at 4 I will go now, because now I have to exactly find what is times 3 of 2. So I'm gonna go here, and this is at line 5. Okay, so like going down, and line 5, it's another function call. So I have to go back to line 1. Okay, and at line 1 I have to execute whatever I'm sending. Okay, so what is the thing that I'm sending? I'm sending 2, 2, 2, 2, like 3 times. So I'm gonna execute line 2, then I'm gonna execute line 3. Now line 3, I will end up to the function call that called me, which is what? Line 5 again. And after that, what I have to do is to go where? To line 6. And after going to line 6, I have to return it where? To line 7. Then, since we've done that function call, I'm going to go to the print, and the print will be at line 8. So the good answer is 1, 4, 4, 5, 1, 2, 3, 5, 6, 7, 8. So at which one here that match this one? So I believe it is what? It is this one, this answer. Okay, now let's take a look at That's a question, and this question will review your understanding for designing a user-defined function. So you need, like, part of solving any question is to understand what is the problem for that question. So what should go in the empty line such that the output of the following program is 7. So let's take a look here. So if I put what y equals 7, and here I put y equal to 7, then I'm going to return 7. So what does that mean? That means whenever I call this function find 5, regardless of the parameters that I'm passing, each time I'm going to pass 7. So this option is correct. Now if I option B, so at option B, if I added here y equal to x minus 1, okay, now I'm sending 5, so I'm adding 8, I'm making it 8, okay, because this is equal to x plus 3, and since x is equal to 5, 5 plus 3 is equal to 8, then minus 1 is equal to 7. That's for w, and that's for y, and then I'm gonna return 7. Okay, so that will work. And here when I say y equal w, from checking this, the previous option, I can conquer that 7, that y equal w will return 7 again. So the answer is all of the above. Now let's take a look at this equation, and this equation is covered in the lecture called, or namely, what is going on in the memory, and was reinforced in the in the last quiz, quiz 3, at which the one that I've solved in the last review lecture. Okay, now from the first impression, you would think that this question measures your understanding of aliasing, which is correct to some point. But the thing is, like, even though that here I'm doing some aliasing, but in this line, okay, I am using a of 2. Now if we take a look, a of 2, this is 1, 0 and 1. Do I have an item at index 2? No, the answer is no. Therefore, whatever I'm doing up, it doesn't matter to me. That's why, even though I give you 5 points, okay, I want you to come to the conclusion that this will will print nothing and will give us an out of range error. So the answer is E. Okay, now let's take a look at this equation, and the same, like, this equation was covered in the same lecture, what's going on in the memory. It will measure your understanding of mutability data type. Okay, and based on the problem statement here, we are designing a new data type or a new data structure or a new object, as we're going to discover that in the upcoming lectures. And at this new data type, which I called it ITI, okay, and this question is something similar to the last quiz as well, but I have changed something in this questions. So ITI, if we check that we created a variable called x, okay, and that x, using the id function, which will determine the location in the memory. The location was x 2022. Now I have updated the value of x, and then I've run the id function, and it's still pointing to the same location in the memory. So because it's still pointing to the same location of the memory, that means that x is what is a mutable data structure, something similar to the list, okay? Because in the case of integers above 1,000, okay, we don't want to deal with interning, or strings, or any kind of immutable objects, x will be pointing to a new location if it's immutable. Therefore, the answer is C. Now let's take a look at this question, and this question was given from the assignment 3, the last questions when you deal a card. So regardless of that, if you read the function, like the description of the function and the examples of the function calls that I have provided you on the doc string, you will understand the behavior of that function. So what does that function do? That functions will deal a new card. I suppose that you're playing any card gaming, and you will have a deck, and you will take some cards from that deck. So how I'm going to do that? If we take a look at here, we have to make an assumption or a hypothesis that the length of the deck, which is the list that has all the cards, is more than or equal 1, and then whatever I'm doing, I'm playing, okay, I'm calling this function. Whatever I'm doing is I'm moving the card to the player list from that deck, and the number of cards from that deck will be what will be reduced based on the number that I have dealt or I have played, to the point that if I have no longer cards in the deck, it will return what an empty list. Therefore, if you recall how you solve this function in the assignment, if you do understand the behavior of that function and you take a look here, that's basically what a while loop. Okay, so there is a condition that I'm gonna keep repeating it as long as what, guys? As long as I is less than what? The number that I'm sending, the number of card, and the length of the is not equal to what? Not equal to 0. Okay, so what I'm gonna do, what I have to do, remember that what I have to append, okay, append what? Append the number of cards that I'm taking from the deck. So how I'm gonna take the card, remember that the deck is a list, so I have to pop the items from that list and append it to the player list. Therefore the answer simply is what? Is why I is less than or equal number and the length of deck is not equal to 1, and you have to put the column here, otherwise you will lose the grade, and you have to say player dot append deck dot pop. Now remember that those are list methods and we need the name of that variable in order to reference them. Okay, now let's take a look at the question 8, and just remember that I'm giving you what? I'm giving you the weight of each question here, like in the exam, as well as how many times does it need to solve this question in the worst case scenario. Okay, now, so why does the following code crash? So I have here, I'm assigning what? A list to variable t, then I am doing t.sort. Okay, now I have covered this in the first week. Okay, I've told you that the length, okay, and the sum, and even the sorted, ed, okay, are examples of functions that can be called with a list, what? With a list argument. Okay, what does that mean? That they will, this one will return like a number, this one will return a number, and even sorted will return a list. Okay, however, what we have another type of functions at which they are supported of the data type. Okay, so what those functions, one of them is the pop, as the one we covered before, t.pop, the variable name or the object's name, okay, which is the list, and pop, as well as what? The sort. Okay, so the sort here. Okay, now t.sort will do what here? This one will never return anything. This function, this method, okay, is on the list, is applied on the reference list. And what does that mean? That I'm not gonna return anything. So Q, in other words, will be assigned to an untype, and I cannot what? Index in untype, or the non-type doesn't support the indexing operation. Therefore, I'm gonna get that error. Okay. Now the same information was reinforced in the jargon of just sorted, the difference between sorted and sort, at lecture 8.3. Okay, so whatever you need to write here, because the function sort does not return anything. Okay, now let's take a look at this function, and this function is something similar to the class at which I have told you that the list or lists are the real deal in Python, and at which I have covered the list comprehension, the 2D lists, and I've given you multiple examples of the 2D list, and I have even given you an example at which it will give a hit for this possible question. You remember the homework I told you to do about the diagonal matrix? Okay, so when we take a look at this function, we will what? We'll pay attention to what? To Aij. That means I am doing what? A double indexing. Double indexing means that I'm gonna deal with what? A 2D list. Now, in that 2D list, the first thing I have to say that this as a precondition, the length of that list has to be greater than what? 1. Okay? So what does that mean? That the length of that list has to be what? Or the list itself has to have some items inside it. Otherwise, it will what? This function will not do anything. Okay? Now, if that list has multiple items, and let's take a look at this example, or this is 2D list, and this is a visual representation to show you exactly what does the following function do. Okay, now so function put in here, when I have a 2D list or a matrix means a 2D list with the same number of columns and the same number of rows. Now inside it, so remember, like, you know, in order to like deal with or manipulate the 2D list, we need a nested loop. Okay, so for I in range X, which is what? Which is the length of what? The length of the or the number of rows in that 2D list, which is equal to the number of columns because it's a matrix. Okay, it's an X to X matrix. So what I'm doing, I'm checking if the number here is equal to 9. Now, if the number is equal to 9, I'm doing another what? For loop, at which what I'm gonna do is I'm gonna update all the variables in that row to become 9. You see that? This is an assignment, as well as to the what? To the column 9, and this one will become 9. Okay, that's exactly the goal of that function. Now let's take a look at this another example. Okay, now this is a 2D list or a 3 to 3 like a 3 to 3 matrix, and at this matrix, okay, we take a look that this function will do nothing for the first row, and for the second row it will be the same. For the second row, whenever I encounter 9, what does that mean here? The condition will become true, and I'm gonna run this this inner loop, okay, in this nested for loops, okay, and what will do? This one will update everything to 9, okay, and even the column at which I found the 9. So this will become 9 and 9, and at the end I'm returning the argument that I have already passed, which is a 2D list. Okay, so this function will modify a X to X matrix because we don't know what is the length of that matrix, and return the matrix modified as if an element in that matrix is equal to 9. It will modify the entire row and the entire column to become 9. All right, now let's take a look at this question. Now this question is something to the textbook problem, or namely like the problem 548. And even in the last review lecture, I have asked you guys to solve these questions, and one of your classmates, Elsa has solved it, and I revealed the answer for this question. Now the question will ask you to find whether a list M2 is what is contained in M1. What does it mean? That means the same items with the same sequence will appear in the two lists. Okay, and you know, I am giving you here like the step-by-step way in order to solve it. Like, you know, so the function will the name is Biden. It will take like 2 lists as the argument, so the type of contract will be list, and it will return a boolean, and at which I have to check whether the elements of list 2 or M2 is what is contained in list 1. So let's suppose that I'm gonna run or visualize this example. Okay, so I have here list 1 and I have here list 2, and pay attention to the locations or the indexing of each item in those 2 lists. Now, do I need, guys, to compare each single item of list 1 with all the items again at list 2? The answer is no. Therefore, whenever I want to do the comparison, I have to do the comparison in a way that I will deduct the length of the second list from the length of the first list. Okay, and after that I will do the comparison in a way that if I compared one, okay, with the items here, I'm not gonna recompare it again. Okay, all the items here, I'm not gonna go back and compare it again. So what does that mean? That means here I have to set the length of or the repetition or the iteration for the outer loop to become what? To become the difference between the length of the two lists plus 1. So I want to make sure that I have covered what? All the items at list 1. Okay, now what I'm doing a flag here, a variable. I name it the flag or found to indicate if I found a variable or not. Okay, and here I'm having an inner loop, and at that inner loop, what I'm gonna do is I'm gonna do the comparison 3 times. Okay, because I'm gonna compare 1 with 1, 2, 1. Okay, so that's exactly what I want to do. So for the length of what? Of M2. And now what I'm gonna do is I'm gonna do the comparison. Now, why did I do I plus j? Because I wanna avoid doing a duplicate comparison. Okay, guys, from list 1. So what does that mean? That means, remember, like I will be equal to 0 and j will be equal to 0. Okay, and what I'm gonna do is I'm gonna compare what? I'm gonna compare this item with each single item in this list, and will update the value of the flag accordingly. Now, what? Okay, now remember that this is what? An inner loop. Yeah, so what does that mean? That inner loop, you have to go back to the outer loop and redoing it again. So if I will equal to 1, okay, now j will what? Will be equal back to 0, and now I'm gonna compare 6 with each single item here. Okay, and at the end, okay, what I'm gonna do, if I have updated the value, okay, or the value of the flag is equal to true, I'm gonna return true. Otherwise, I exhausted all the comparison and those items are not in the list. Therefore, I'm gonna return false. And I even asked you in the review lecture to go and try the solution yourself and to use the Python visualizer yourself. Now I'm explaining like each problem very fast because I assume that you have comprehended all the skills from the previous weeks. Okay, now let's take a look at this example, and this example combines both the understanding of the mod plus the understanding of how I'm going to deal with lists. So the name of that question is called Omega, and Omega take a list and return true. So again, the type of contract will be list and true, and will be true if, or check if, at least one element of that list is divisible by 3. So what does that mean? I have to iterate for each item in that list, and if I encountered one single item that is divisible by 3, or that is a factor of 3, that means I have to exit that loop and return true. So remember, the function should be efficient. It should stop as soon as the result is known. So that means I have to incorporate the break. What? The break statement, because this break statement will do exactly what the questions ask. Okay, what the question asks. Okay, so imagine that here is a customer asking you to do the following, and he told you, I want that function to stop. When? As soon as I know the result. So you have to act, you have to be what? You have to act like smart and effectively. Okay, so how to do it? Remember, like this will take a list and return true. So, okay, I'm gonna take what? A list of integer, and I'm gonna return a boolean. Okay, now I will what? I'm gonna assume, I'm gonna apply the same principle I have solved the one in the prime question in test 1. So each that list is innocent until proven guilty. So what does it mean? That I'm gonna use a flag and I will assign it to false. Okay, and whenever or it's actually the opposite. So each list I'm sending is what? will give me false until proven otherwise. So for each, now remember, like now here, what kind of loop pattern we are using? We are using the explicit loop pattern at which I'm iterating over items of that sequence. And if the item that I'm getting here is divisible by 3, what doesn't mean that if V mod 3 equal to 0, B equal to true. Okay? And then I'm gonna break. Okay? Or like some of you might use the iteration over the implicit iteration at which they will find the length of that of the input argument x, okay, the length of that x, and will range over that length, as well as what they're gonna do, they will say return the true here, and if we exhausted the whole for loop, I'm gonna return false. So both solutions will work. Now let's take a look at the last question here, and in this last questions you have to write a function called sigma, and this function will take a list of integer and calculate the length of the longest sequence in that list. So a sequence is composed of 2 or more consecutive items. Now this is already provided to you, and I've given you 15 minutes to read it. But let's take a look at the examples here. So now I have 1, 2, 3. Now this is a sequence. Okay, how many numbers in that sequence? Okay, because they 2 is an incremental of 1, and 3 is an incremental of 2. So this is a 3. Now here, let's take a look at here. Do we have any sequenced items? No. Because remember, the sequence compares of 2 or more consecutive elements of increasing value. Each value is bigger than the previous one with 1. Okay, so no, I have nothing here. Now if we take a look at here, we have this sequence though, so I returned 2. And if we take a look, I have only this 1, 2, 3. That's it. Okay, and then here I have 5 and 6. So this is what? This is 3 sequence, this is 2 sequence, and this is 4 sequence, and then I have 7. Okay, so I'm gonna return the longest sequence. So what is the longest sequence? Is 4. Now for empty list, and pay attention to this, I'm returning 1. Okay, so I'm based on those test examples and based on the problem statement here, what I'm gonna do, remember, in this course, you have to master how to solve computational problem. Okay, now what will be the algorithm to solve that? The algorithm to solve that is I have to use a nested loop pattern, and as that nested loop pattern, I will have a counter, and that counter will be updated as long as I'm having a sequence. Now, in order for me, why did I choose a nested loop pattern? Because I might encounter multiple sequences, and I need to get the sequence that represent the longest one, or I need to get the count that represent the longest sequence. Okay, so with that being said, okay, now we'll take a look at the solution. I have here the function name sigma, and it will take a list and will return an integer. As a hypothesis, I have to make, or as a pre-assumption, that x is not empty, or the length of x is greater than 0. And what I have to do is I have assigned I to equal to 0, and max is equal to 1. Why did I put max is equal to 1? Because in the case of the empty list, I have returned 1. Okay, now inside this, I'm gonna iterate over over the length of that list. Okay, so as long as it's all the items, as long as length of x minus 1, and I'm gonna make the count equal to the max first, and after that, while I am within that list, and the item in the current situation is or in the current position is equal to the item, okay, at the second position minus 1, because it's incremental. I have to update I have to update and I have to update the count. Okay, and this will keep repeated to the point that I'm gonna have the number, I'm gonna have in count what the last what the number of elements in the last what in the last sequence in that list. Okay, number of items in the last sequence. But remember that I don't want to just get the last sequence. I want to get the maximum or number of items in the what in the longest sequence. Therefore, I'm going to compare count to max. Okay, if what? Okay, if count is greater than max, I'm gonna what? I'm gonna update the value of max. Okay, and at the end, what I have to do is to what? Update the value of I for sure. And at the end, what I'm gonna do is I'm gonna return max. Okay, so why did I do that, or why do I have this if statement? Because as I told you, you might encounter a situation at which you have multiple sequences. Okay, and this way, they like until this line. Okay, this function sigma is written in a way to capture what the last sequence, the number of elements in the last sequence. Okay, or like if we are starting from the beginning, is to capture the number of the elements until what? Until I don't have a sequence. Okay, now what I have to do is to make sure that I'm keeping my eye on what? On the number of elements for each sequence that I have, and I'm gonna compare it to what? To like I'm gonna compare each new sequence. Okay, the length of each new sequence with the length of the previous sequence. If that's true, I'm gonna update the what? The length of the maximum sequence that I have encountered so far, and at the end I'm gonna return it. That's it. That's all. And this is the what? This is the this is the solution for the whole questions in test 2 at its all version. Now, one might ask me, okay, so did I surprise you in this test? The answer is no. I have provided you with all the examples, with all the in my lecture notes and in my recordings. I have even brought some questions from the labs and from the assignment. Labs and assignment. Okay, and here lectures. Okay, now even at this question, which is supposed to be challenging, okay, that thing was covered in what? The skills to solve this is covered in your labs, guys. Okay, and I'm really sorry, but this is the way that I'm gonna continue running the course until the end of this class. And if you wanna cheat yourself by, for instance, if we take a look at the assignment 3, we will see that one of you guys posted the first question at check, and he got the answer. Okay, now you don't believe me? Let's move on for what? For the second question, and so on. Okay, so basically you are what? You're cheating yourself. Okay, function Momo. Like Momo is the way that I use my nickname. Okay, Momo, and what they posted it. Now let's take a look at even at Course Hero. We go here. Wow, function Momo is right there. What else? We can see what else? What else? Anyway, guys, with this, I am concluding this video, this short video, and I'm gonna catch you in the next one. Bye-bye.